Glencoe Accelerated Math Lesson 4.2 on negative exponents today. So, we know that exponents mean repeated multiplication of some base number. Well, when we look at page 141, at the bottom, it gives us a little table. And it shows us what happens with the base of 10. But I want to show you what happens when we have a base of 2. Okay? What does 2 to the third power mean?
2 times 2 times 3.
Okay, that equals 2 times 2 times 2. What is 2 times 2 times 2? 8. Okay, that equals 8. What does 2 squared mean? That means 2 times 2. That equals 4. 4. What would 2 to the first power mean?
2.
Just 1, 2. Okay, so what happens as we go from 8 to 4 to 2?
It decreases.
It decreases. How does it decrease?
It goes to 0. Oh, the exponent.
Okay, so we have one fewer multiple of 2. Do each of these get divided by 2?
Yes.
Yeah. Okay, so if we're going to 2 to the 0 power, that means that we have 2 divided by 2.
It's 1?
Which equals 1.
Wait, what?
So if going from 2 to the third to 2 to the second, we divided by 2. 2 squared to 2 to the first, we divided by 2. 2 to the first divided by 2 would give us 1. Okay. What do you think 2 to the negative first would be?
Negative 2. Negative 2. Negative.
Let's raise a hand and see. What do you think 2 to the negative first power might look like? Yes, sir.
220?
Okay.
I meant like 2 over 20.
2 over 20, all right.
Or 0 over 20. Or 0 over 20.
Okay.
Negative 1 over 20.
You think negative 1 over 20?
I think it's negative 2.
Think it's going to be negative 2? Did you have something to say? Yes, sir. Did you have something to say? Okay. Anybody else? Okay. Well, if we're taking all these and we're dividing by 2, this would be
0.50.
take the 2 divided by 2 times 2 should be 1/2. Or 1 over 2 to the first power?
No. Yeah. No.
Hold on. Yes.
1/4.
Okay. So that would be 2 divided by 2 times 2 times 2, which equals 1/4, because those cancel, right? And those cancel. So we're left with 1 over 2 and 1 over 2 times 2, which is 4, which equals 1. 1 over 2 squared?
Yeah.
Will we do the same thing with 2 to the negative third?
Yeah. Yes. It's 4 2s.
So, what did our values that had a negative exponent turn into? So we turn them into positives, okay? Was the base negative or was my exponent negative? My exponent was negative. Okay? So we took something that had a negative exponent, we made it a positive exponent. What else did we do? Yes. We did simplify it. We turned it into a fraction. Hold on just a second. When we turned it into a fraction, okay? So here's a problem using negative exponents. Here's our solution, or here's the same thing written with positive exponents. What was my numerator?
If it's a positive exponent, the answer that you get if it was a positive exponent.
Denominator? Okay. What was my numerator?
8.
Do you think it's ever going to change from 1?
Yes.
No. So when we are looking at negative exponents, when we convert it to writing it with a positive exponent, we're going to have to turn it into a fraction. And the denominator is going to have a base with the positive exponent. This is 2 to the first, that's 2 to the negative 1. 2 to the positive 2, 2 to the negative 2. 2 to the positive 3, 2 to the negative 3. Did the number in my exponent change? No. Did the sign change?
Yes.
Yes. Okay. Can we take a fraction like this and turn it into a number with a negative exponent?
Yes.
Yeah. Absolutely. Sometimes it's going to be easier as we work through the chapter. Sometimes it's going to be easier to work with negative exponents. So if we're given a problem like this, it will be easier to convert it to this. Okay? Today we're just switching between the two. What questions do we have at this point in time? Yes, ma'am.
May I take a picture of
This isn't getting erased, so wait just a second. Okay? Alright. The other thing, for those of you that like to take pictures as notes backup, you can always take a screenshot of the video. So, you know, at home tonight, pull it up on YouTube and take a screenshot. Okay? That's okay.
We can take a picture of that.
So, this is what page 141 talked about. But if we look in our book, it does it with a base of 10. It does it with a base of 10. I thought it might be more useful to do it using a different base. Okay?
Yes, ma'am.
Alright, let's look at example 1, please, on page 142. On page 142, let's look at example 1b. It says m to the negative 4th power. M to the negative 4th. And it asks us to write this using a positive exponent. So how can I write this, where I have a variable as a base, using a positive exponent? Let's start with this question. What format is my answer going to be in?
Fraction.
It's going to be a fraction. Okay? Do I know what the numerator is going to be?
No.
1. My numerator is always going to be 1. Okay? What's my denominator going to be then? M to the 4th. Do I need to do anything else to that? Nope. That's it. We converted from a base of the variable m raised to the power of negative 4, and we wrote that using positive exponents. That's all that our problem asks us to do. Yes, ma'am?
You don't have to put a negative sign.
No. When we put it in the form of a fraction and it becomes a denominator, that takes the place of my negative sign. Question? Yes, sir.
Why is it always like, why is 1 always the numerator?
1 is going to be the numerator because, like, if we look over here, when we got to the 0 power, we took the base divided by itself. That equals 1. Okay? So we have 1 and something. Here, when we had 2 to the negative 1, we have that 2 divided by itself. So we started out with 2 over 2 as being our kind of base value. And then we divided that again by 2. So when we cancel those 2's out, that creates 1 whole as our numerator. Okay? Yes, sir.
So can we just, for the M4, can't we just take that subtraction off of there and just make it into a fraction and put 1 above it?
So this explains why what we're doing works. Okay? This is what you need to be able to do. Okay? Questions about this? No? Does it look a little easier now that we know what we're doing?
Yeah.
Yeah. Okay. Let's look at another example just to make sure that we've got it. Please look at example 2b. I'm liking the B's today. 2b says that we're going to take 100, so 1 over 100, and it wants us to write this using a negative exponent. So I've got a question for you. If there's 2 different ways that we could write this. We could say 100 to the negative first power, correct? We could. Is that the smallest base that we can use for 100? No. What's the smallest base that we could use for 100? Yes, ma'am. 10. So then what would our exponent be? I'm sorry? You're saying 10 to the negative 2. Why would it be a negative 2? I'm asking all the difficult questions today. Yes.
Because
Because what?
Because you're taking away a 0.
Kind of. Yes, ma'am?
Because you divided 10 because like it tastes like 2 cents and divided it.
Good. So, because we know that 100 is 10 squared, we can write 10 with an exponent of 2. That would give us 100, correct? But because it's the denominator of our fraction, we need to make it negative. Okay? When we have a denominator of a 1 with zeros behind it, we can, we can rewrite it using a base of 10 and count the zeros. The number of zeros is going to be your exponent. Okay? If we're just talking millions, billions, trillions, etc., then our exponent will be positive. If that's in our denominator, you make it negative. Okay? But if we have a 1 and zeros behind it, we can say that our base would be 10 and our exponent is the number of zeros. Questions? Yes, sir. What's what for? This? That's 2b. It says that we're looking at example 2b from the book. In case you lost your spot. Alright. before I set you free today. Woohoo! Look at example 4 on page 143.
143?
Yes, we're looking at 143. Looking at example 4. And example 4 asks us to evaluate 4a to the negative fifth if a equals negative 2. So this means that we have 4 times, what does a represent? Negative 2. That negative 2 is taken to the negative fifth power. Did I need the parentheses around negative 2?
Yeah.
Yes. Because that variable a, that positive variable a, represents the quantity negative 2. Okay? And because the variable a is taken to the negative fifth power, anything that a represents is in those parentheses. Okay? Alright. This means that I have 4 times, can I write 2 to the negative fifth using positive exponents? Because I really don't want to have to calculate negative 2 to the negative fifth power. And that's what we have to do because we need a single number answer. How could I convert this? How could I write negative 2 to the negative fifth power using positive exponents? Yes, ma'am? Okay, very good. Now let's figure out what is negative 2 to the fifth power. So what's negative 2 times negative 2?
Negative 4. I mean positive 4.
Positive 4. Positive 4. Okay, what's positive 4 times negative 2?
Negative 8.
Negative 8.
Negative 8. What's negative 8 times negative 2?
Positive 16.
Positive 16. What's positive 16 times negative 2?
Negative 32.
Negative 32. So this would be the same as 4 times 1 over negative 32?
Yeah.
Yeah?
Yep.
Okay. Can I multiply that? Can I multiply 4 times 1, negative 1/32? No, when we take it from here, put it in fraction form, the variable becomes, or the exponent becomes positive. Okay. I can multiply these two things together, can't I?
Yeah.
Give it a ghost denominator of 1. So what's 4 times 1? What's 1 times negative 32? Negative 32. Can this be simplified?
Yes.
Yes, it can. They're both even.
Oh, yeah.
All right. So what is 4? What is it? Negative 4/32 simplified. Yes, sir. Negative 8 as a whole. Yes, sir.
1 over negative 8.
1 over negative 8. If you want to put your negative sign outside the fraction, that's okay. Alright, but there has to be a negative sign somewhere in your answer. Questions? Yes, ma'am.
Can I take a picture of it?
As soon as we're done, as soon as I turn off the video, I will let you take a picture to back up your notes.
Are you gonna cut that out?
3,